Good morning, everybody. Time for the warm up. Again, this beautiful April day we got here. Hopefully, you're going to get all your work done early and enjoy some of this awesome weather. Okay. All right. Happy Earth Day +1, right? Yesterday was Earth Day, and I know some of you are doing some Earth Day activities. Have fun doing that. Okay. I know that the people, everybody else benefits, but you will benefit yourself by feeling good about what you did. Okay. All right. Copy that down. I'm going to let you copy down the top part first, and then I'll let you copy down the other part, and then we'll go over it. Okay. Hopefully that was enough time. Again, you just press pause. Gives you all the time you need, right? And here we are with the bottom half. We have a couple of area and perimeter problems, and they have variables. Right, so you can't find out what the answer is, but you can simplify what it is. Remember, x plus 3x plus 2 gets me halfway around for the perimeter. Need another x and another 3x plus 2, and then simplify as best you can. And then remember, for a rectangle, to get the area, it's the length times the width. So it's x times 3x plus 2. And I want to see if you do that correctly. When we get done, when you get all done with both of those, then we're going to say, what if x is 2.2? What's area and perimeter then? You get to go substitute. Same idea here with the parallelogram. Again, you got to add up all the way around. A plus B plus A plus B. That's the perimeter. The area is the base times the height. That B, even though it's on the top, since it's a parallelogram, will also be the same thing on the bottom. So the base is B, the height is C. Okay, and then it gives you some numbers to plug in. One problem to do for proportion at the bottom. Okay. All right. Copy it. Okay. Let's get some answers here. What do we got here? First, got a couple diamonds. Again, these diamonds I've sort of reverted a little bit. So it's not a whole lot of kids were raising their hands. Okay. Now, if you're one of those kids who've been doing the warm ups all along and those diamonds are just too easy for you, they're not worth your time even. Okay. It's some good practice, but send me an email. And if I get enough responses of kids saying, "Hey, I want some of those challenging diamonds again," I'll add a couple of those. And we got the KenKens. So, what two numbers have a product 28 and a sum of 11? Hopefully, you figured out that's 7 times 4 is 28. 7 plus 4 is 11. How about 42 and 13? Again, if you've been having that integrity all along, this is the easiest diamond ever because you've seen it so much. 7 times 6 is 42. 7 plus 6, 13. I want to remind you, if you don't know your facts, these are more difficult, just like life is. If you don't know your facts, get that composition book out, get the multiplication chart out, and these easier diamonds are always going to be here. So you go find the 42 on here, find out what numbers work there, and see if when you add, you get the same thing. You go find the 28, find out what numbers multiply together equal 28, see if when you add, you get a sum of 11. Different things you can do. Okay. All right. What is the square root of 1/4? Hopefully you figured out that 1/2 times 1/2, or 1/2 of 1/2 is a fourth. All right. And hopefully you figured out the square root of 1/9 is 1/3. How about the square root of 4/9? Well, 2 times 2 is 4. 3 times 3 is 9. Square root of 25/64. That's going to be 5/8. How about 16 over 81? Don't fall into the trap. I get a lot of kids who put 8/9 on here, right? What times itself equals 16? 4. So that's to be 4/9. How about 49 256? 7/16, and 100 121s, 10/11s. Okay, the square root of 100 over 121 is 10 over 11. Okay, here we go with the KenKens. See if we can figure this out. I'm subtracting two numbers to get one. So I can do 3 minus 2, but I can also go 2 minus 1. That doesn't help me much. Okay. I do know that when I multiply two numbers to get 3, I have to use a 3 and a 1. I can't use a 2 in this box or in this box. I need a 2 in this row. Boom. I'm started, right? Now, I also know that I can't use a 3 in this box or a 2 in this box or in this box. I need a 2 in this row. It has to go down here. And if I have a 2 in this row and in this column, I have a 2 in this row and this column, but no 2 in this row and this column. Where does the 2 have to go? And at this point, you can just say 2 plus 2 is 4 plus how much is 7? Okay, and I think you can finish this. Okay, so I'm going to give you a chance to go ahead and try. Press pause again if you haven't finished it already. All right, 2 plus 2 is 4 plus how much is 7? So a 3 has to go there. I got a 2, I got a 3. This should be a 1. I got a 2, I got a 3. This should be a 1. 1 times what is 3? That should be a 3. 3, 2. That should be a 1. And this should be a 3. All right, because I got a 2 and a 1, a 2 and a 1. I'm missing a 3 in this column and this row. Let's just double check. Is 2 minus 1 1? Yeah. Do I multiply these two numbers to get 3? Yeah. Do I add these 3 numbers to get 7? Yes. And do I multiply these 2 to get 3? Yes. All right. Already got a few kids saying, can you get me some more of these? I like them. Okay, so I'm making some copies, some more challenging ones that kids could pick up Thursday or Friday if you're a roomie. If you're a Zoomie, send me an email. I'll send you some attachments. They're kind of fun. Okay, the perimeter is x plus 3x plus 2. That gets me halfway around. Plus another x plus another 3x plus 2. Now, I am going to what they call combine like terms to make that simpler. Okay, an x and a 3x, a 2, these are the numbers. Okay, and what do we call those? Anybody remember from yesterday's homework? Those are called constants. Okay, if a 2 will always be worth 2. So I'm putting all the constants together. It looks like I got a 2 and a 2. Those are all plus 2, so that's 4. Now let's put all these x's together. I got an x and I got a 3x. So an x plus 3 more x is 4x. Okay. Now really what helps sometimes, some kids, they put a 1 in front of that x. A 1x and a 3x is 4x. A 1x and a 3x is another 4x. That's a total of 8x. So 8x plus 4 is the perimeter. And that would be whatever units. If it was centimeters, it's 8x plus 4 centimeters. Okay, if it was miles, it's 8x plus 4 miles. Now, yesterday, one of the things we did is we worked backwards to factor out a number if we could. I don't know if you know what goes into 8x and what goes into 4, but 4 does. So I could have pulled that 4 out and say this is 4 times what equals 8x, 2x, and 4 times what equals 4, 1. So this would be, I think, another way of writing the perimeter of this. Okay? See if that helps us later. Now the area is just the length times the width, so it's going to be x times 3x plus 2. X times, this is parentheses, 3x plus 2. And this is when we're using that distributive property. And remember, that means this x, it's like you're dealing cards to people. Everybody gets the same amount. So I've got to go x times 3x plus, not plus 2, plus x times 2. So what is 3x times x? That's 3x to the second power. X times x is to the x to the second power, right? And what is x times 2? That's 2x. So this is the area. And you would say square centimeters, and you might write square units on that since we didn't have any units, just so you remind yourself. Okay. All right, the perimeter of this is a plus b plus a plus b. A plus b plus a plus b is how many a's? 2 a's. How many b's? 2 b's. So the perimeter is 2a plus 2b, inches, miles, whatever it is, right? What's the area? It's just the base times the height. This is the easiest problem on the page, huh? Area equals BC. That means B times C. Square units, right? All right, now what if we have a number here? If x equals 2.2, okay, then I got to go 8 times 2.2 plus 4 to get the perimeter. And remember, 8 times 2.2 is like 8 times 22, and then I figure out where the decimal goes. So 8 times 2 is 16, carry the 1. 8 times 2 is 16 plus 1, 17. But really that was 2.2. I had to move the decimal over one spot to the right to pretend it was 22. So I have to go back and move it one spot to the left to get my answer. So the perimeter equals 17.6 units, right? Okay. How about the area? Now I got, where are we here? The area is x times 3x plus 2. So 3x squared plus 2x. And if I said 3x squared plus 2x and said x equals 2.2, well, I got to go to do x squared. I got to go 3 times 2.2 to the second power plus 2 times 2.2. Okay, so I got to do a little work here. 2.2 times 2.2 is like 22 times 22, right? Pretend there's no decimal. 2 times 22 is 44. Put a placeholder. 2 times 2 is 24. So 484. But I had to move this over once and this over once to pretend those were 22s instead of 2.2. So that's 2 spots I got to go back in my answer. So this ends up being 4.84. So I got to go 3 times that. And 2 times 2.2 is 44, but I moved that over once, so I go back once. All right, so this is what I got so far. This problem ends up being hard, huh? So I got to go 3 times 4.84, pretend like it's 484, and multiply it by 3. 3 times 4 is 12. 3 times 8 is 24 plus 1, 25. 3 times 4 is 12 plus 2. Okay, but that was 4.84. I'd moved it over twice. I got to move over twice in the answer. 14.52, 14 and 52 hundredths plus 4.4. What do we do here? We make sure when we add decimals that we line up the decimal. Don't put 4.4 here. Put that decimal down first. And then you see how that's kind of going in the middle there? Okay, if that's confusing, add a 0. You're allowed. 2 plus 0. 5 plus 4, the decimal comes straight down, you add, and 14 and 4 is 18. So 18.92 on that one. 18.92, and that was the area, right? And that's going to be square units. Okay? All right. Area and perimeter here. If the A is 2.5, right? So I got to go 2 times 2.5. And B equals 6 1/4. I got to go 2 times 6 1/4, and then add them. So I can do 2.5 times 2 in my head. Okay, I just know $2.50, $2.50 is $5. If you didn't do that, then you want to create a problem that's easy by making both these fractions. Okay, so remember the C method. 2 times 2 is 4 plus 1, 5 halves. And how do you turn 2 into a fraction? Okay, get ready to write this down if you don't know. Okay, write down all these directions. Okay, ready? Boom, boom. All you do is put a 1 under it. Okay, now I can cross cancel if I want first, or multiply straight across the top, straight across the bottom. And again, 10 over 2 is the same as 5 over 1, which is 5. And that's what I said, huh? Now you believe me? But I wanted to show you how to do it if you didn't have that sort of memorized or how to sort of do that part in your head. I can multiply almost anything by 2 in my head. 2 times 6 1/4 is 2 6s and 2 4s. Okay, another way of doing that, just like this one, is do this: 6 1/4 and 2. Okay, so 2 times 6 is 12. 2 times 1/4 is 2 fourths, which is 1/2. So 12 and 1/2. So here we got 5 plus 12 and 1/2 equals 17 and 1/2. That is the perimeter. Area, B times C. C is 2. B is 6 and 1/4. We already did that, didn't we? Right? Because we had to do 2 times 6 and 1/4 anyway. 12 and 1/2 square units. All right, last problem is this proportion. And remember how to solve proportion. Sometimes you're lucky and you can treat it like an equivalent fraction, but I don't know, 12 times what equals 18? Well, it's 12 times 1 and 1/2 or 3 halves or 1.5, but I don't expect you to know that. What I expect you to know is if I can't solve it easy in my head like this, what do? And that's when you remember you can cross multiply. What does that mean? Well, I'm going to make a cross here. I'm going to go 12 times x equals 25 times 18. And I'm not going to write 12 times x. I'm going to write x times 12 equals 25 times 18. Okay? Now, 25 times 18, we got to figure out what that is. 8 times 5 is 40. Carry the 4. 8 times 2 is 16 plus 4 is 20. All right, that makes sense. 8/4 is $2. Put a placeholder. 1 times 25 is 25. So I get 450. Now remember, when I solve an equation like this, my goal is to get the x by itself. That's called isolate the variable. So I have to get rid of that times 12. How do you get rid of it times 12? No, you can't erase it. It's in pen. No, you do the opposite. What's the opposite of times 12? Well, it's also called the inverse operation. It's divided by 12. And if I do it to this side, I got to make sure that my equation stays in balance by doing the same thing to the other side. DTSTTTOS. Okay? Do the same thing to the other side. So if I divide this side by 12, I need to make sure I divide this side by 12. Now, why did I do that? Because times 12 and divided by 12, they cancel each other out. All that's left is x over here. And now all I have to do is figure out what is 450 divided by 12. That's some long division. A lot of you don't like yet. Okay, once you get good at it, you won't mind it so much. Now, I know that 3 times 12 is 36 and 4 times 12 is 48. So 4 is too much. I got to put a 3 here. And that's 36. Now I subtract. Okay, 45 minus 35 would be 10, so 36 is only 9. What do I do now? Bring down the next number. How many times does 12 go into 90? Well, is it 8 times? Well, 8 tenths and 8 twos, 80 and 16, that's too much. It's going to be 7 times. 7 times 2 is 14. Carry the 1. 7 times 1 is 7 plus 1, 8. And that makes sense. 7 12s is 7 10s and 7 2s. So 7 10s is 70. 7 2s is 14. 70 and 14. Okay. Now I subtract, I get a 6. What do I do now? Well, I have my choice. I can have my remainder go on top, divisor on the bottom, and get 37 and 6 12s. But if you saw that 6 12s, you'd say, wait, I can simplify that. 6 goes into the top 1 time and the bottom 2 times. 37 and a half. The other thing I can do is I can add a decimal and bring it up, add a 0, bring it down. And 12, I know this from the clock, goes into 60 5 times. 37.5 or 37 and a half. Well, which one is it? They're the same, right? 1/2 and 0.5 are the same. So this ends up being 37. Let's go ahead and say 0.5 on that. All right, everybody. Hope you did well on this. Hope you learned something. I hope you have a great day.